Good morning, my dear friends. How are you? How is your preparations? Everything is going good. I'm expecting the same. So, this year I want good results from you all. Okay? Because your preparations, your hard work will definitely pays off. Okay? So, with this, we are starting for the today's live session, my dear friends. And today we have taken two questions from the real numbers. Okay? These are good questions. That's why I thought to brought to you just for the revision purpose you can understand. Okay. The first question is that six bells commence tolling together and tolls at interval of 2, 4, 6, 8, 10 and 12 minutes. Okay. So few bells are there. Okay. So in the bells are like this. Okay. Just I'm drawing this just so that you can have some good interest with these. Okay, these are the bells. Okay, there are such six bells. Okay, and all those bells are ringing at an interval of 2, 4, 6, 8 and 12 minutes. These are ringing at an interval of 2 minute, 4 minute, 6, 8, 10 and 12. Okay, all these are in minutes. Okay, so we need to find in 30 hours how many times do they toll together. So in 30 hours, how many times the bell will ring? Okay, this is the question to us. So my dear friends, into this question, first we need to understand that definitely one bell is ringing after 2 minutes, another or after 4 minutes, then after 6 minutes. So when we are starting from zero, if you start from zero, if you say this is the number line, this is plus x, right, and this is the zero, right, then you can say this is the starting point, this is the starting point. So the bell start ringing from this zero origin, ringing, right, at 0. Okay, so that means if the bell starts ringing at this place, right, if the bell starts ringing at this place, then the first bell will be ringing after 2 minutes like this. Okay, here we have 2, and from the starting the second bell will ring after, let us say this is not as per a scale, but let me show you, after 4, the third after 6, then 8, then 10, then 12. So my dear friends, till 12 minutes of time, all of these 6 bells are ringing only once. Only once, mind it. Because this is 2, 4, 6, 8, 10 and 12. Right? So after 12 minutes of time, this sequence of bell, their ringing time will again repeat. Okay, so they will repeat after how much time? So definitely we'll find the LCM over here. Okay, LCM of these numbers, 2, 4, 6, 8, 10 and 12 minutes, right? So when we find the LCM of 2, 4, 6, 8, 10 and 12, it will be easier to go on the answer. Okay, let us see how. From 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. All this is in table of 12. Table of 2, isn't it? Now after this, 2 is again can be taken to 1, to 1. 3 will not be divisible by 2. Then 2, 2 times 4. Then 5. Then 2, 3 times 6. After that, you can take next one, 3 is there as a common. So take 3. 1 as it is, 3 1 times 3, 2 will be as it is, 5 will be as it is, and 1 times. So the LCM of these numbers 2, 4, 6, 8, 10, and 12 is 2 into 2 into 3 into 2 into 5, right? So let me write it quickly. 2 into 2 into 1 will be the same. We'll leave it into 2 into 5. So when you will multiply it, it will be coming as 4, 3, 12, 24 into 5, 120. So 120. Okay. So after 120 minutes of time, all these bells will come to this origin. This condition will be regenerated. You mean to say why? Because after 120 minutes of time, all the six bells will just achieve this position of origin, and they will, then the counting will start again from this. So this situation will again repeat, right? So in 30 hours, how many times? So my dear friend, in 30 hours total times, in in 30 hours they will ring, the bells will ring for 30 into 60 minutes. Just convert into minutes divided by this LCM of 120, right? This 120. So when you just solve it, you will get certain answer, but that is not your answer, my dear friends. Okay. What we will do, we will simply do this calculation. 60 will divide 120 into 2 times directly. Oh, let us save the time. And 2 will divide 30 in 15 times. So 15. So we will get 15. So is our answer is 15, that in 15 minutes of time, all the not 15 minutes, these bells will ring 15 times. All these six bells will ring 15 times. No, they will not ring 15 times. But try to understand, this 15 is not your answer. Okay, this is wrong. This is wrong. Why this is wrong? Because we have started counting from this position. Okay, as I said, after 120 minutes of time, after 120 minutes, after 120, which is the LCM, right? This situation will repeat. So that means this 15 plus the starting point when all the bells started ringing together. Okay, the origin, at the origin all the bells ring once, right? So that means 15 plus 1, this will be coming as equal to, this will be coming as equal to 16, right? This is your answer, my dear friends. So all these six bells which started ringing together, okay, and they ring after this much interval of time, respectively 2, 4, 6, 8, and 10 and 12, then they will ring again, they will ring totally 16 times in the duration of 30 hours. Okay, so this is your answer, my dear friends. 16 times, 16 times, right? So we have solved the question. The question was that six bells commence tolling together and toll at intervals of 2, 4, 6, 8, 10, and 12 minutes respectively. In 30 hours, how many times do they toll together? Okay. So this is solved, right? Now quickly going into the second question, okay? Because we have we need to solve the second question for today. The second question for today is that this is also from the real number, okay? That so that 6 power n can never end with 0 for any natural number n. So 6 power n, 6 power n can never end with 0 for any natural number n. So we do, just to prove that this can never end with 0. Definitely it will not end with 0. Why? Because I am showing you. If you find the factor of 6, it will become 2 and 3, isn't it? it will become 2 and 3. Now, from here, if 6 power n is the number into the consideration which is into the question, then here just apply power n into the RHS and it will become 2 power n and 3 power n, right? Hi Abhilashna 816. Hello my dear friend, good morning. So this will be the combination. Then we can say that 6 power n can be written like this. So my dear friend, here what we can do, 2 power n and 3 power n. What are the factors? You know, actually 0 will never end with, right? Because it will come with, if you see the factors of 5, it should be 0, it should be 0 or 5 into the last, right? It should be 0 and 5 into the last, right? Then into this case, if you see this number 6 power n, right, can be written as the factor of 2 and 3, right? And 2 and 3 will not have any factors except 2 and 3 will give you 5, and 5 will not have any factors other than 0 and 5, right? So definitely we can say 6 power n will not be having this one, right? Let me just a minute, my dear friend, just a minute. See, there is some. Hello, hope my voice is audible now, right? So we are showing that 6 power n, 6 power n can never end with 0 for any natural number n, right? Because the factors of 2 or the factors of 3, okay, the factors of 2 or 3 will. So we can see that yes, if we see that the question is that the 6 power n will never end with 0. So to end with 0, just see like this way. Just don't take in this way. Just see like this. If to end with 0, right, then definitely what we will do, it should be having a factor of 2 and 5 only, because this will only give the numbers, this will only give you the number ending with 0, right? This will only give you the number ending with 0. But here you can see it is 2 and 3. Here you can see 2 and 3, not 2 and 5, right? Here is 2, it should be 2 and 5, but the factors of 6 to the power n is here 2 and 3, but not 2 and 5, right? So to end this with 0, it should be either of this, I mean to say not either, both of these 2 and 5, then only it will end with a factor with 0, right? The question was that so that 6 to the power n can never end with 0 for any natural number. So definitely, my dear friends, if any natural number n is there, right, then definitely the number on the base is 6, and 6, the factors of 6 are 2 and 3, you can see. So to get in the end 0, we should have the we should have we should have the numbers 2 and 5 in place, then only we will be having this 0, isn't it? And this 2 and 5 is not there, it's 2 and 3, right? So we can say that yes, 6 power n can never end with 0 for any natural number n, right? So in this way, this explanation can be given, and these steps can be written and explained, so that it will be you will get full marks across this, right? So with this, I think we can wind up today's session for real numbers, my dear friends. We have taken only two questions. Both of these are conceptual questions, and these questions may come into your board examinations. Okay. Thank you so much for watching. Take care. Bye bye. And just when you are going to solve this question, just remember, just remember that whenever any bell question is coming to you, you just that they are ringing in this much of time, just take the LCM. When you take the LCM, and if the question is asked that in how much time, in the given interval of time, here we have 30 hours. In 30 hours, how many times these bells will ring, right? This was the question. So first you take the durations of all the bells, right, and take the LCM, and whatever the total time given to you, 30 hours. So 30 into 60, you can see here 1800 minutes are there. So 1800 minutes to be divided by your LCM of 120. That's why 120 is there. You can see here 120 is there, right? You'll get the answer 15, but this is not your right answer, right? Because the bell started from origin. So this one count should be considered. So that's why I added 1 year, and final answer is 16. So this you need to consider in solving any such questions of bells, or any, suppose some boys are playing and they're repeating after a jump like this. Okay, so this should be considered, my dear friend. Okay, thank you so much for watching. Let us connect into the next session. Bye, dear friends. Bye bye.